Well, how do you do? How are y'all doing today? That was pretty somber. You guys don't want to learn here about what I got here? I got the uninterruptible power supplies. Has anybody ever heard of those? You know what they do? You know what they protect from? Well, if anybody hadn't seen any, I got a couple spread around the room there. I got 3 of them on those tables right there. I got a couple different types. I got some small ones, like a personal use, like an enterprise use, and a server rack one that you'd have like a big server room. As you can tell, those things get pretty big and pretty heavy. What UPS is, it's kind of like a big old battery that you have your computer run off of. And most of them are just there as the emergency backup use. Some of them are there for like a sustainable power, but most of them are usually just like an emergency, like 5 or 6 minutes to recharge, or not recharge, but to basically keep your computer from shutting down wrong. Basically gives you just enough time to go, uh-oh, click, 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 turn off, and then you're good. But there's some of them that they have in like higher security areas that are bigger and cost way more, that they can sit there and run for days, weeks, hours, but those ones are really big and really expensive, and pretty much all of them are going to do the same thing except for really cheap ones. They might not protect you from some of the bad power, but does anybody know what bad power is? Alright, what is bad power?
Surges, low and high frequencies that are unexpected.
There is. So you got surges, which is what most people realize, like when the power just goes out for a second, comes back on. You got those, and then you got brownouts where the power goes down and it comes back on. Say like when the air conditioner kicks on, you ever seen the lights kind of dim a little bit and come back on? That's a brownout, and that's pretty bad for your computer if you're running it. It could mess up your hardware in there because a lot of the hardware is very sensitive. So how many people have a $5 power strip protecting your $1,000 computer? Kind of doesn't make sense, does it? You got a $5 power strip that's basically just going to protect you from the kind of powers, but it's not going to protect you from all the other powers. That's where UPSs come in handy. So they got all kinds of different UPSs. You got UPSs that can protect your Ethernet cable, they can protect your phone cable, they can protect coaxial, and they can protect your power. Basically, anything that has like power running through it, you can pretty much protect it. And then it also conditions is what I was telling you about the brownouts and everything else on there. So I got a little video here to keep you on, or to show you how they protect you.
So imagine this, you're sitting at home working on the latest and greatest cat photo in Photoshop, then after multiple hours of your dedicated hard work and attention, all of a sudden, you lose your I am not an electrician, so I can't stand here and tell you why some homes are more prone to power outages than others, or for that matter, why some places have issues with flickering power and some don't. You see, it's one thing to go down for a while in the middle of a storm or during excessive heat in places like California where the power grid is incapable of keeping up, but it's another thing to lose power for only a few seconds for what it seems like no reason at all. For example, my most recent home that I bought loses power about once or twice a month for 3 to 4 seconds at a time without any reason at all, while my previous home that was over 60 years older than this one lost power in the most aggressive storms and was usually down for a few minutes or longer. So, as you would imagine, once I moved to my new place, I was forced to provide protection for my equipment that I have been putting off doing for years. In today's video, I want to cover some of the main reasons as to why you might want to consider protecting your computer with a UPS or an uninterruptible power supply. Diving right into it, let's start off with the most obvious concern, data protection. Just like in the intro, you could be working on anything at any time and experience a loss of power. Even if it's for only a microsecond, it's enough to lose power to your computer and lose everything that you're working on. Now, for some people, they have built habits around constantly syncing their projects as they go along. This can mainly be credited to the instability of some software applications or add-ons for that software. For example, in Adobe Premiere Pro, you might want to try to apply an effect to a clip that will reduce the amount of noise in the video. And then, for no reason at all, everything goes white and the program crashes. Now, if you're stuck to your habit and constantly save your project, you might have only lost maybe a few changes. But if you happen to have fallen into the zone and forgot about your dedication to the save button up top, then you might end up letting out a few choice words directly at your computer. The same habits can be formed for people who have unstable power connections, and the same frustrations can drive them crazy. Even if you hit the Control S all the time, losing any amount of work is just annoying. On top of that, if by pure chance you're in the middle of saving a project and you lose power, you can still lose your data by it being corrupted. This brings me to my first explanation on what a UPS can and cannot do. A UPS by design is hardly ever meant to be a power replacement. Unless you invest large amounts of money into huge or multiple devices, you're only going to get emergency benefits from a UPS. Depending on what you get or how much you spend, you can usually expect to get 4 to 8 minutes of computer usage after a power outage. This is of course plenty of time to save and close your work, and thus avoiding the disaster of having to start over on your project. But what about physical damage to your data from a power outage? Well, this can be a long topic, so I will try to keep it brief. But the basics are, sudden power loss to a hard drive carries very little chance of actually physically damaging that drive. What it is probable, though, is that the PC could be in the middle of writing or modifying a file, and when the power goes out, it's unable to complete that action. This is the #1 reason for people to lose large amounts of data. It's not that the data is technically gone either. It's that while it was in the middle of modifying the file, major changes were being made and new data was being transferred from your RAM. When the power went out, the drive was stuck with part of the old file and part of the new file. This gives you a corrupted file, and that usually means it's unusable. As a side note, this can be even more devastating to a RAID setup, but I don't really want to go down that rabbit hole just yet. Okay, so UPS is sounding pretty good at this point. It protects your data and your hard drive while allowing you to finish things up before shutting down your computer in the event of a power loss. But what if you don't actually have anything that you work on that's crucial? Maybe your home PC is only used for basic things like browsing the internet or working on non-critical projects. This brings me to my second point, surge protection. In the event of a power loss or flicker, a surge of power can rush through your wires and cause a large amount of damage to just about anything electronic. Now, I know what you're thinking. You're protected by an awesome $5 surge protector that you bought from Walmart last year, so you're good to go, right? No, you're not. While in some cases the really cheap surge protectors might help you, by design it's best to just look at them as only power splitters. The amount of protection they actually give you is negligible at best. To get any real protection, you're going to need to spend at least a minimum of $30 to $40 on a higher quality device. This might sound like a lot when you're used to only dropping $5 on surge protectors, but why would you want to drop thousands of dollars on a computer only to protect it with $5 surge protectors? It sounds kind of stupid, especially when a bad surge of power can fry many of your PC components in the blink of an eye. Well, with the UPS, you not only get the previously mentioned benefits of backup power, but you also get advanced surge protection. The UPS will condition the power to supply the most optimal voltage for your computer at all times. And when a basic UPS can only cost you about $100 to $140, factoring the benefits of surge protection helps you to justify the additional cost. Okay, so at this point, let's say that you're sold on the idea of a UPS. Now you just need to know how to shop for one. This can actually be really simple as long as you know the basics. Starting off, let's talk about something called pure sine wave. While shopping for a UPS, you will find two different major types to choose from. One will provide a simulated sine wave, and the other provides pure sine waves. In the interest of keeping this simple, I will link in the description to read more on the difference. But for now, on the most basic form, a pure sine wave UPS is your optimal choice.
Now we're going to switch back. Alright. So, basically, like you said, prices can range anywhere from $30 all the way up to hundreds of thousands of dollars for the big server ones, like enterprise ones that I was talking about earlier. We got, like you see on the picture there, we got little bitty ones about like this big, and then we got ones that are bigger than the whole table put together. They can range from all kinds of different densities and services, but basically they're all going to do about the same thing, just with different amounts of uptime. So I got a little video here showing how a data center uses the UPS there. This is a little short video.
Technology systems operating in data centers are routinely notified of maintenance requiring uninterruptible power supply, UPS system transfers. IT frequently understands these transfers are reason for concern, but may not understand the specifics of the event. This video is an example of a typical process to transfer the IT load from utility power to generator power, which allows technicians to safely perform maintenance on the UPS. Before any critical maintenance is performed, a safety meeting with all participants occurs. During this meeting, they will review the method of procedure. The MOP is a document that describes in detail the sequential steps that will be taken and signed off prior to performing each step. Next, they will go over all necessary safety precautions for the given maintenance event. After the safety meeting is finished, the next step is to get the generators running. This is done from a remote location where the paralleling gear can initiate and sync all the generators together to support the electrical load. This is a schematic representation of how power can be provided to critical IT loads. The yellow line indicates the input power is flowing from the utility distribution through the UPS modules and into the critical IT load. Now that the generators are warmed up and ready to accept the critical load, the next step is the transfer from normal UPS power to generator power. The transition takes approximately 3 seconds to transfer load. During this time, the batteries will provide current to the critical IT load as illustrated. Once the transfer is complete, the load is now supported by the generators. As illustrated, electrical power is still flowing through the UPS modules. The UPS modules are not yet safe to work on. The next step is to perform the static bypass transfer, which is the first step to electrically isolate the UPS modules. This transfer is automated and initiated through the UPS controls. As illustrated, the power flows from the generators through the static bypass into the IT load. This transfer is a closed 50-millisecond transition, meaning the transfer is transparent to the critical loads. After that step is performed, you can initiate the transfer from static bypass to maintenance bypass. This is a manual closed transition operation where both sources are briefly parallel. This transfer is also transparent to the critical loads. At this point, the UPS modules are electrically isolated and the UPS maintenance can be performed. Once maintenance on the UPS has concluded, the reverse steps are performed to return the UPS to the normal utility service. Here at the market.
So, do you guys think you should get one now? Does anybody get any questions or anything I can answer here? Making you think maybe you should get one, maybe not? No? Anybody think you should get one? You're gonna upgrade to the $20 one now? Well, hey, that's an upgrade. All right. Well, there we go.